Good afternoon all. Today's topic is Introduction to Operating Systems, and objective of this video is to provide a grand tour of the major operating system components and to provide a coverage of basic computer system organization. And let us define what is an operating system. Operating system is a program that acts as the intermediary between a user of a computer and the computer hardware. And the operating system goals are, there are two goals, main goals. The primary goal is user convenience and the secondary goal is efficiency. So primary goal is user convenience is to execute user program and make solving user problems easier and to make the computer system convenient to use. And the secondary goal is efficiency, use the computer hardware in an efficient manner. Computer system structure. Computer system can be divided into four components. Those are hardware, operating system, application programs, and users. Users are people, machine, other computers are the users. Application programs can be defined as the way in which the system resources are used to solve computing problems of the users. Example for application programs are word processors, web processors, database systems, video games. And hardwares are the basic computing resources, for example, CPU, memory, and I/O devices. Operating system can control and coordinate use of hardware among various applications and users. This is the pictorial representation of four components of a computer system. The computer hardwares are the resources, and this users can use the application program to make use of the computer hardware to solve the problems. And operating system can control and coordinate the computer hardware among many users and application programs. And there are two views of operating system. Those two views are user view and system view. First one is user view. To explain user view, there are many situations. First situation is most computer users sit in front of a PC. In that case, OS is designed mostly for ease of use with some attention paid to performance. We never think, in that case, we never think about user resource allocation or resource, how resources are using by these users. We never think about that. And second situation or second condition is user is sit at a terminal connected to mainframe or mini computer. In that case, OS is designed to maximize user resource utilizations. And the third case is users sit at workstation connected to network of other workstations and servers. In that case, OS is designed to compromise between the individual usability and resource utilization. And the second view is a system view. In system view, OS is defined as a resource allocator and control program. OS as a resource allocator, it can manage all resources, and OS will be deciding which user can use this particular resources for now. Those all things are decided by OS as a resource allocator. So OS decides between conflicting requests for efficient and fair resource use. And OS has a control program, control execution of program to prevent errors and improper use of computers. And our next topic is operating system definition. There is no universally accepted definition, and the one program running at all times on the computer is the kernel. Everything else is either a system program or an application program. And for a computer to start running, for instance, when we power up or rebooted, it needs to have an initial program to run. That initial program is the bootstrap program, and that bootstrap program is typically stored in the ROM, and it can initialize all aspects of the system. In the sense, register to memory to device driver to everything is initialized by that bootstrap program, and it should know to load the operating system kernel and start execution. So after that, operating system should execute one initial program in it. After that, operating system will be waiting for any event to occur. And occurrence of events signal to OS with the help of the interrupt. So interrupt transfers control to the interrupt service routine generally through the interrupt vectors, which contain address of all service routines. And incoming interrupts are disabled while another interrupt is being processed to prevent the lost interrupt. And trap is a software generated interrupt caused either by an error or a user request. And operating system is a interrupt driven. This is the interrupt timeline. Next topic is computer system organization or a computer system like see one or more CPUs and device controllers connected through a bus, and they will be accessing memory, shared memory, and the concurrent execution of CPU and device competing for the memory cycles. And this device controllers will be managing different types of devices. So for example, disk controller will be managing disk, USB controller will be managing different USB devices, and graphic controller will be managing monitors like that. And each disk controller will be having their own local buffers. And CPU moves data from or to main memory or to or from the local buffers. And device controller informs CPU that it has finished its operation by causing an interrupt. And IO device and CPU can execute concurrently. And next topic is storage structure. Storage structure is, we know, main memory. All programs should be there in the main memory for execution. And main memory is the only large storage media that the CPU can execute directly. And main memory is size wise, it is very small and it is volatile structure. So to store your data, we need some extension of main memory, that is the secondary storage, and it is large and non-volatile storage. And the example of secondary storage is magnetic disk, and the disk surface is logically divided into track, which are subdivided into sectors, and disk controller determine the logical interaction between the device and the computer. And storage hierarchy, and this based on speed, cost and volatility, and this is the hierarchy of the device, storage devices. Registers is very less size but high speed and high cost, and magnetic tapes is high size wise is very big and less speed and less cost. And caching is a process of copying information into faster storage system, main memory, faster storage system to from the less storage system to faster storage system, copying information, that is caching. And already explained this diagram. This is IO structure diagram. CPU and IO devices is connected through bus, and they are accessing the memory, shared memory. And to start an IO operation, there are device driver, device controllers also. This device controllers are connected to, will be managing different kind of devices. And device drivers is the OS side program, and the device driver loads the appropriate register within the device controller, and this device driver will be controlling each device controllers, and device driver will be loading the appropriate registers within the device controller, and the device controller in turn examine the content of these registers to determine what action to take. Suppose if it is a read action, then the controller starts the transfer of data from the device to its local buffer. Once the transfer of data is incomplete, the device controller informs the device driver via an interrupt that it has finished the operation. The device driver then returns the control to an operating system. And the direct memory access, like this interrupt driven is for low volume data. If you have very high volume of data, it is very difficult to execute. So we are going for direct memory access. Direct memory access used for high speed IO device able to transmit information close to memory speed. Device controller transfer block of data from buffer storage directly to main memory without CPU intervention. Only one interrupt is generated per block rather than the interrupt per byte. That is direct memory access. I hope all of you understood this topic. Thank you.